Now, now one thing to remember, sometimes we may have to look on more than one nearest neighbor. Let's discuss in the next slides. We can also change number of neighbors to look upon, because let me explain this. As we discussed in the example, you are a good person, I am a bad person. So a friend of yours is also a good person. But it's not always the case. Maybe your friend have other bad friends. So he must be classified as a bad person. So that's why we may have to look not only on one neighbor, but on more than one neighbors. For example, let's say we are having another data point here, and this is my data point. I want to classify it as a triangle or circle. So what my model will do, my model will calculate the distance. Let's say I'm calculating the distance for now for only one neighbor. I will increase this number, but for now only one neighbor. So what I think is that this data point is more closer to this, right? This is what I think. You may be thinking that this blue point is more closer, but according to me, this red triangle is more closer. Okay, Python will calculate the exact value by the formula, so we don't have to worry about that. This is a one neighbor. Okay. Now using one neighbor, we classify that this is a triangle, right? Now what happens if we were using two neighbors? Now the second neighbor, what it will look like that this is right? Now we are looking at the two closest neighbors, number one and number two. So these are two. Okay, now if one is circle and the other is triangle. So what should we classify? Now it's a problem. That is the reason why we don't use even number of neighbors. We always use the odd numbers so that we have one class as majority and other class as minority. So using two give us no useful result. Let's use three neighbors. Now the third closest point is what I think is it may be this or it may be this, right? Okay, this is a circle also here, but what I think that this is more closer to this data point. Maybe it is more closer to this data point or this data point, but let's say this is more closer to this data point. So now let's calculate the majority. The majority is one triangle, other triangle, and one circle. So two triangles and one circle. The majority is of triangle. So my model will think it is a triangle. Now it's a plus point. Using one neighbors, we will classifying it is it as a triangle. Using three neighbors, we again classify it as a triangle. Now, sometimes the you may use 7 to 8 data points, 7 to 8 nearest neighbors, so your results will become more robust. Let me give you another example in this page. Okay, let me use this data point here. It will make let's see what will happen when we go through it. This is the data point. Now let's draw the neighbors. Using one neighbor, I think I will have this. Using two neighbors, I think I will have this, right? This is my thinking. I am not calculating the exact distances, or I am not having any measurement instrument here in my hand. But okay, let's do this. The third neighbor is what I think is okay. This looks like the third neighbor. And now the fourth. Okay, let's use five neighbors, right? I can use five or I can use three. Using the three neighbors, here I have three neighbors. It is clear that we classify it as a triangle because there are two triangles and only one circle. But now let's say that using the fourth, this data point, but it is very far away. So I think before that we have this data point, right? This is more closer. And after that, we have this data point. And now these are the five most closest data point or to our test data point, which is this test data point. Now let's calculate the majority. Three triangles and two circles. Still, the triangles have the majority. So that's how k nearest neighbors work. It will calculate the distances to the training data points, and whatever label they will have, it will classify that label to the test data point. Now, for your clearance, it is like mandatory to note that whenever we have a data point, till now, I am training I am training the model. I am not specifying the number of neighbors. So when I am not specifying the number of neighbors, it will automatically detect that there is only one neighbor to look upon. So it will look at only one neighbor, and in this case, let's say it will classify it as a triangle. Or if we had a data point here, it will look at one data point and okay, it is a circle. So that's how the k nearest neighbors